wonderful students at home. You are welcome to another beautiful edition of Eko Learners Support for WAEC and NECO candidates. I remain your chemistry instructor, Mr. Oluwaleke. The topic before us today is factors affecting rates of reaction. Please sit back and enjoy the journey with me.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Factors affecting rates of chemical reaction. Learning objectives. At the end of this class, students should be able to define rate of reaction, mention factors that affect rate of reaction, and explain the factors that has been mentioned. Rate of chemical reaction. In our everyday life, we see a lot of reactions going on around us. A lot of reactions, some of them happen very fast. Some of them happen very slow. In fact, some of them take years before it can happen. So this is what we are discussing under rates of chemical reaction. How fast or how slow a reaction is. So the rate of chemical reaction vary greatly depending on the type of reaction. Some reactions are fast, some are slow, and some occur at irregular speeds. Simply put, the rate of a chemical reaction is the amount in moles of the reactant used up or product formed at a given time. So the reactant used up or product formed at a given time. So that's what rate of reaction is telling us. What does that mean? You can take a simple equation. Let's say hydrogen plus oxygen to give us water. Hydrogen plus oxygen to give us water. So the rate of reaction has been defined as the amount in moles of the reactants used up or product formed at a given time. So if I want to measure the rates of this reaction, let's assume I start with 5 dm cube of hydrogen, probably at 5 minutes interval or 10 minutes interval, the whole volume of hydrogen has disappeared. So that shows that a reaction has what? Taken place. So that's why it is said that the amount of the reactant used up or product formed at a given time, or I'm trying to measure the volume of steam that is what? Produced. So the rate at which you produce will determine how fast or slow that reaction what is. So that's why rate of reaction is change in concentration of reactants or products divided by time taken. Now, these are the factors that affect rates of chemical reaction. Students, please ensure you know these factors. They are very, very important. These are the factors that affect rate of chemical reaction. The first one is nature of reactants. The second one is concentration or pressure when it concerns gases. We have temperature of the reaction. We have surface area of the reactants. We have presence of light. And we have presence of catalysts. So these factors affect the rate of a what? Reaction. Nature of reactants. Nature of reactants. I said it then that some reactions are very, very fast, some are very, very slow, and some take ages. This might be due to the nature of the reactants. Nature of reactants. What do we mean by nature of reactants? Let's take a reaction of iron and hydrochloric acid. Reaction of iron and hydrochloric acid. So if you study this reaction very well, we find out that the evolution of hydrogen gas is very slow. The evolution of hydrogen gas is very slow because iron displaces the hydrogen, so the evolution of hydrogen gas is very slow compared to when we use zinc or sodium. When we use zinc or what? Sodium. If you use zinc, hydrogen will be produced in a faster rate. So if you look at that, that shows that iron is different from zinc. Zinc is different from iron. Sodium is different from iron. So their nature matters to determine the rates of what? Chemical reaction. You may also observe it in our different classes. There are some students, whenever they are taught, within a minute or 2 minutes, they tend to understand everything the teacher has said. Why there are some, it might take the teacher repeating that class for the third time or second time before they get to understand. Why there are some, probably due to what they are facing, they might not even get to understand when the teacher explains this up to 4 times. So, what is that telling you? That means in your class also, there's a reaction that is occurring. The teacher is teaching. Is there assimilation? How fast is the assimilation by the students? So, one student is different from another student. So, nature of reactants is telling us all this. With gold, there is no even reaction. Yes, that is true. If gold reacts with what? Hydrochloric acid, the reaction does not even happen. People are saying for iron that is very slow. With gold, it does not even happen at all. No matter what you do, it does not happen. Even if you increase the concentration of the acid, put the gold in smaller particles, no matter what you do, it does not happen. There's a reason for that, because gold cannot displace hydrogen from hydrochloric acid. Gold is below hydrogen in our electrochemical series. So that's what nature of reactants is what is telling us. Different reactants with their different characters. Concentration of reactants. An increase in concentration of the reactants will result in a corresponding increase in effective collisions of the reactants, and hence results in an increase in reaction rates, the rate of chemical reaction. While a decrease, of course, also decreases the rate of what? Reaction. So, for example, a mixture of hydrogen and chlorine will react twice as fast if the partial pressure of both of them is doubled, or either of them. The concentration of solid and liquid reactants is unaffected by change in pressure. Yes, we have said it before that pressure is only applicable to gases. Pressure is only applicable to gases. So, concentration, the higher the concentration, the higher the rates of reaction. The lower the concentration, the lower the rates of reaction. This explains more to us what increase in concentration does. In this first diagram, the concentration is not much. We have just 2 of the reactants, of a particular reactant. While in this one, the concentration has been increased. We have 4, 5, 6, 7, 8, 9, 10. We have about 10 of it. So the concentration has been what? Increased. So what does that mean? That means there will be more effective collision. As this one is bombarding it, this one will be bombarding it, this one will be bombarding it. It's like it's present in many places. So there will be more effective collision and reaction will be faster. Reaction will be what? Faster. So that's what we are saying. In this reaction, because the concentration of the reactant is small, it's hard for the green molecules to make collisions with the what? Blue molecules. A higher concentration of the blue molecules makes it more likely for the green molecules to make what? Collisions. Because it's only effective collision that can lead to a reaction. Take note of that, students. It's only effective collisions that can result in a reaction. If there is no effective collision, there is no reaction. Temperature. How does temperature affect the rate of a chemical reaction? The rate of almost all chemical reactions increases with increased temperature. It is found that a temperature rise of 10 degrees centigrade doubles the rate of a reaction. So in a nutshell, the higher the temperature, the higher the rate of reaction. Why is this so? Because if you look at it, temperature will give the reactant molecules greater kinetic energy. Greater kinetic energy. They tend to move faster. They tend to collide faster, leading to more effective collision that gives us results, which is the reaction. But once the temperature is low, they are not energized. They don't have much energy. And as such, it cannot give effective what? Collision. How can we liken this in our house, in our environment? You observe, students, that when the weather is very cold, you are not usually active as when the weather is not cold, when we just have a warm weather. Yes, that's what we are saying here. Because when we have a warm weather, the temperature is higher than when the weather is very cold. So when it is warm, you are more active, you run here and there, you play here and there. But when it is very cold, wow, you probably stay indoors most of the time, especially this weather we are in now. You tend to cover yourself, you tend to, play less. So that's what we are talking about here. So when the temperature of the system is increased, the heat energy is supplied to the reactant particles. The increase in energy results in an increase in the number of particles with activation energy or more. Thus, collision becomes more frequent and reaction proceeds what? Faster. Yes, that's another point. If you increase the temperature, it will make more reactant particles to have energy, which is equal to the activation energy. Activation energy. Activation energy. What is the activation energy, students? That is the minimum energy that all reactant molecules must possess before they can form product particles. That is the minimum energy. Once they don't have that minimum energy, they cannot form products. So there must be a minimum energy. So that's why it is said that the increase in energy results in increase in number of particles with activation energy or more. So that's the effects of temperature. Yes, this diagram exemplifies what we have said. So the higher the temperature, the higher the rate of reaction. The next one is surface area of reactants. Surface area of reactants. When the surface area of a solid is increased by breaking it into smaller pieces or by grinding it to powder, there will be greater contacts between the reacting particles and hence increase the rate of reaction. In other words, the greater the surface area of the reactant, the faster the rate of the reaction. Surface area of reactants. It is applicable to solid. It is applicable to solid. The higher the surface area, the higher the rate of reaction. The lower the surface area, the lower the rate of reaction. If you observe this very well, our mothers, or some of us students that are viewing me, apply this at home. You cannot imagine you as a student going to the kitchen, you want to cook, you want to include Maggi in your food. Please, how do you do it? Do you just remove the wrap and just drop the Maggi in the soup? Wow, you said, that would be catastrophic. Because at the end of the day, the food will not be sweet. And you might end up eating your Maggi yourself. But what do we normally do? We take time to squeeze the Maggi. We squeeze it into smaller particles, break it down before we now put it in our soup mixture. So that will make it faster and that will make it our soup sweeter. That's application of surface area of reactants. So the higher the surface area, the higher the rate of reaction. So if you see it in a question, that's when a solid is in powdered form or when it's in a solid form, the one that is powdered form sure has a higher rate of reaction than the one that is in liquid form, as shown in this place. So this diagram is also emphasizing what we have said, that the higher the surface area, the higher the rate of reaction. The higher the surface area, the higher the rate of reaction. If you look at it very well here, the blue is 4 here, but now it has been put in greater number, is in higher distance. So there's tendency for the reaction rate to increase. Catalyst is another factor that affects rate of reaction. We all know what a catalyst is. A catalyst is a substance that alters the rate of a chemical reaction, but remains chemically unchanged at the end of the reaction. A catalyst provides an alternative route for the reaction. Thus, a positive catalyst provides an alternative route with lower activation energy, while a negative catalyst provides an alternative route with higher activation energy. So, a catalyst, it increases the rate. A positive catalyst increases the rate of a reaction. The function of a catalyst, take note of this. You will see it in some examination question. The function of a catalyst is to lower the activation energy. It's a very important point. To lower the activation energy. Let's liken it to your high jump. Let's assume you are having a high jump in school. You're having a high jump in school. And the height that the student has to jump over is very high. But after we reduce it, many students will be able to fly over. So on reducing that height, many students will be able to fly over. But once it's very high, just very few, probably 1 or 2, might be able to fly over that barrier. So that's what we are trying to say. The activation energy is like a barrier that all reactant particles must pass before they can form products. So reducing it for them, that's what the catalyst does. It will reduce that barrier for them. So many reactants can form products. These are characteristics of catalysts which you are very familiar with. I'll just mention some of them because I know my students are very intelligent. They know this. This is also in biology. So it alters the rate of the reaction. A catalyst is specific in action. The effect of a solid catalyst is improved by increasing the surface area. We have said that before. So these are the characteristics of catalysts. So we have said that this is the initial energy barrier. The reactants must be able to reach this height before they form products. But the catalyst makes their work easier. It reduces that energy barrier. So that's why the word we read earlier, it changes the routes. So instead of taking this pathway, so this is the new pathway that is formed. So it reduces it. So hence, the reaction will be faster and more reactant particles will have the activation energy and the product is formed. Reaction will be faster. Lights, reactions that are influenced by light, are referred to as photochemical reactions. Reactions that are influenced by light are referred to as photochemical reaction. Examples are these. Photosynthesis is a very common one, which I know many students know from their biology. So without light, the light parts of photosynthesis cannot what? Take place. Reaction between methane and chlorine, and as you have seen, all these reactions are influenced by light. Take note of this. Take note of this. Reactions that are influenced by light are called photochemical reactions. Please let's take note of that, students. Okay, this is also showing the emphasizing what we have said. So the farther this light is from this place, the slower the rate of reaction, because this requires what? Light. So that's why the distance is measured at each point, when it is far and when it is near, and we'll check the what, the reaction rate. So this showing what we have said. Is also another one that shows how lights affect the rate of what? Reaction. So our practice questions. I believe my wonderful students understand how what we have done, and they'll be able to do this. So let me just give you just some few seconds to bring up these answers for me.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Very good. We should be through by now. The first question, how does an increase in temperature typically affect the rate of a chemical reaction? How does it affect? Very good. Your answers. Nobody failed it. Everybody echoed increase the rate of the reaction. Thank you. That is the answer. It increases the rate of a reaction. Increase in temperature will increase the rate of reaction, as we have explained. So let's now go back to that. The second question, which of the following is not a factor that can change the rate of a chemical reaction? Very good. The answer is atomic mass. We all got it. We all got it. Is the odd one out. Surface area, concentration, pressure, temperature, they're all factors that affect rate of chemical reaction. But atomic mass is not there. It's not there. Number 3, what is the role of a catalyst in a chemical reaction? What is the role of a catalyst? Increase the activation energy. Does it increase the activation energy? I did not remember telling you that. So, boy, you got it wrong. A catalyst does not increase the activation energy. Instead, thank you very much, it lowers the activation energy. That's why I use the high jump as an example to you. It lowers the activation energy so that many reactants will be able to what? Scale through. So it does not increase the activation energy. Let's check the other options. Let's check the other options. Let's check the other options. Okay, C, increases the number of collision. Increases the number of collision. D, it lowers the activation energy required for the reaction to occur. Very good. That is the answer. It lowers the activation energy for the reaction to what occur. So D is our answer. Number 4 is taken from the theory part of our exam. Define the time rate of reaction. I believe you can define rate of reaction. Yes, thumbs up. I very much love that. Mention 3 factors that could affect the rate of reaction. Wow, we have all done it. We have all done it. You can mention more than 3 factors if I were to ask you. Thank you for those feedback. State 2 properties of a reaction that could be used to determine reaction rate. Yes, 2 properties. We can use the mass. We can use the mass because as the reaction rate is proceeding, the mass will either be increasing or decreasing. And we can also use the pH. We can use the pH. The page also tells us how to determine the reaction rates. So, thank you very much. Please, students, please always revise your work, always practice, and always be good. So, thank you very much for listening with rapt attention.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Remember, for any comments, suggestion, reaction, please feel free to reach out to the link displayed on the screen. Thank you very much.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.